Hello from Rappel Cybersecurity. Welcome to the Cartography of cybersecurity related standards and regulations of road vehicles. The purpose of this presentation is to make a deep dive in official text, including standards, regulations, best practices, guidelines related to vehicle cybersecurity, to help you distinguish with them and identify the ones which will eventually be applicable to your project. We will cover cybersecurity core texts that are cybersecurity themselves and related texts which have certain dependencies with cybersecurity, and then the conclusions at the end. In this presentation, we covered the regulations and standards, guidelines, and other legal texts that are shown here. On this slide, only a listing and a simple categorization with respect to the types are presented. Full names can easily be found by a web search. In the rightmost column, you can see the texts which are currently in development, hence not available for purchase or consultation. However, we still provide the names and some brief information because they will shape the future of road vehicle cybersecurity. You will see that there are several safety-related texts. The reason that we provide them here is safety can no longer be without cybersecurity. This was introduced in ISO SAE 21434 and UNR 155 already. The safety features of modern vehicles must all be protected from any cybersecurity threats. That means the vehicles have to be cyber secure to be able to be safe. In this slide, we describe the cybersecurity cortex and the relations between them. We put UNR 155 at the center because it's the source of CSMS at organization level and type approval at vehicle level. As you might remember from UNR 155 training, these are the two main parts that make up this regulation. To reach these two main objectives, we make use of the resources shown in this slide. For the CSMS part, UNR 155 regulation, the clauses 5, 8, 12, 13, and 14 of the ISO SAE 21434 are utilized with the help of ISO PAS 5112. In fact, ISO PAS 5112 is directly related to ISO SAE 21434 and extends the ISO 19011 guidelines for auditing management systems to the automotive domain. In other words, it's an audit document which will help us to audit the target CSMS of an organization. There is also a paid tool of VDA, the ACSMS, that helps us conduct audits in a more organized way. For the project part, we use the word assessment rather than audit. The clauses 6, 7, 9, 10, 11, and 15 are utilized with the help of VDA SPICE for cybersecurity. We should have sufficient guidance to assess the project with the help of these two texts. At the upper part of the diagram, you see ISO SAE 21434 certification outputs. In fact, UNR 155 compliance is not the only ultimate goal of the text mentioned in the slide. As you might remember from the trainings, ISO SAE 21434 is much more anticipated than UNR 155 in the world. So without having to seek a compliance with the UNR 155 regulation, ISO PAS 5112 and VDA SPICE documents can be used as a guide for ISO SAE 21434 certification. But we guarantee that it will not be as straightforward as it seems. You will definitely need a consultancy support for this. There is one last document at the bottom, which is UNR 155 interpretation document. It is provided by UNECE to support the interpretation of UNR 155 regulation. It has several references from other standards, especially from ISO SAE 21434. In this slide, we will see together the cybersecurity related texts. On the left, you see different UNECE regulations and their dependencies. At the innermost cell, there is the UNR 155 cybersecurity regulation. In upper cell, there is UNR 156, the software update regulation that requires compliance with cybersecurity. Similarly, UNR 157, automated lane keeping regulation in the upper cell, requires compliance with software update. The outermost rectangle is the new General Safety Regulation. It requires compliance with cybersecurity and lane keeping. However, there is no direct statement in it that requires compliance with software update. On the right, you see the standards and their dependencies. We have ISO 21434 and ISO 26262 functional safety at the core. ISO 24089 software update clearly requires compliance with cybersecurity and functional safety standards. However, ISO 21448 safety of intended functionality, known as SOTIF, does not directly require compliance with any of the three previous standards. SOTIF is complementary with functional safety and cybersecurity. Therefore, a table is provided in the introduction to highlight how the causes of hazardous events are handled by different standards. Nevertheless, there are always certain dependencies and overlaps. Cybersecurity related text continued. ISO TR 4804 considers safety and cybersecurity by design, as well as verification and validation methods for automated driving systems. In addition, it outlines cybersecurity considerations intersecting with objectives for safety of automated driving systems. This standard will be replaced by ISO CD TS 5083. This standard, yet under development as of January 2024, is expected to comply with main nominative and regulatory texts for automated driving. ISO SAE AWI 8477 Cybersecurity Verification and Validation is a work in progress. This document includes technical considerations on the planning and execution of verification and validation of the cybersecurity of items and components of road vehicles in the context of ISO SAE 21434. It also includes strategic approaches for verification and validation, applicable methods, distribution of verification and validation activities between customer and supplier, timing, and execution. Likewise, ISO SAE 21434 objectives and approaches are emphasized rather than technical solutions. ISO SAE AWI PAS 8475 is also a standard in development that describes the relationship between CAL and TAF and their application to cybersecurity projects. It also provides guidelines to determine and use CAL and TAF for cybersecurity engineering of items and components. As we know, CAL notion was already introduced in ISO SAE 21434. It's a classification methodology that scales the cybersecurity engineering process with respect to the cybersecurity assurance needed for an item or component. The new concept of TAF, that is the target attack feasibility, describes the maximum or expected attack feasibility rating for a given item or component under certain conditions. Those which are attack proximity, attacker profile, and subset of the attack path. Certain CAL and TAF information are expected to be propagated through the supply chain to ensure that distributed development process requirements are satisfied. Keep in mind that the information presented in this slide is derived from working group meetings and it is subject to change. The conclusion. As we have seen in previous slides, cybersecurity compliance is definitely a must-have as it lies at the inner circle of software update, safety, and other incoming normative texts about automated driving. In other words, we have to first ensure cybersecurity compliance to be able to comply with software update, safety, and automated driving. Increasing complexity of automotive systems has rendered relative normative texts complex as well. In addition, they are constantly evolving. Nothing is simple and will never be in the future. Therefore, a compliance strategy is definitely needed for the OEMs and the suppliers. Dependencies and overlaps should carefully be analyzed to make a compliance planning, not to miss any details and to meet the deadlines. And the last but not the least, quality consultancy is most of the time the key element to reach to your goals. Don't wait till the last minute to get one. Thanks for listening. Don't forget to subscribe to this channel and follow the LinkedIn page not to miss any updates. See you soon.